Okay, thank you. I think we can start. So my name is Jakub. I'm building Paradigm, and today I would like to tell you about coding with AI. So I'll start with a quick introduction to vibe coding, which you probably already know well, and its limitation, how coding agents see code, how we interact with code right now, and what is next. So right now we see that we actually don't read code because AI agents are so good at coding that we don't have to do this anymore. And how do we handle that actually? Because it's like good to know what actually happens in the code. So some people say my code reviews just got better. I have AI reviewing my code. Other people say that I don't read code, but I everything else. I take a look at every error, every explanation, how agents work, and what happens, like the whole orchestration. And it kind of works. This is an example of a project that I built in just a few hours on a hackathon 1 week ago. It was a fully functioning app that was telling you which event to attend based on your preferences. It was scraping Luma, and then if you needed a new site that you scraped events from, you just created a plugin, and it was literally being vibe coded, one-shotted by agents. So this is incredible what you can build, and we even managed to deploy that. We did another app that was doing the vibe GTM, so basically doing lead enrichment based on scraping a lot of internet to know what your sunning persons are. And it's also worked, and it was fully vibe coded, which is incredible. But the problem is that it breaks at scale. If you want to deliver something to production, you cannot just blindly click enter and yeah, let's do it. So the problem is that when the complexity of your project increases, it's much harder and harder for your agents and for you to navigate it. And we should do something about it, but more on that later. So, but why does it happen? Why our agents break at scale and are not as good and the quality decreases? So the problem is context rot. The bigger the context for your agent, the worse the output is. And this is one of the benchmarks that I found. So with the increase in input length, the performance drops significantly. And this happens consistently for all of the models that we have. This is another benchmark, basically the same story. So how coding agents actually see code? For Claude, this is done via grep. Agent tries to figure out what is the correct pattern to find a thing that you are looking for. And it turns out that this works very, very well. But as you can imagine, grep doesn't semantically actually knows what happens. It's just trying to match a keyword correctly. So it always misses something. And you have to iterate and iterate to find what you actually want to find. Cursor does something a bit different. It also does grep, but also on top of that, it also indexes your code base like in classic rack. And this is a visualization of how embeddings actually look in a 2D space. So the problem with code is that code is kind of similar to itself, like how one function is different from the another. And when you try to look at it, all of the dots are actually quite close to each other. And already these clusters are very nice, but usually it's not as nice as here. So, but actually we should do this differently, right? Like code has its structure. You have catalogs, folders, functions, classes, calls, and AI agents completely ignore that and don't look at it and do this in a naive way. And there is a structure that you can extract from code. But yeah, more on this structure later. So what we are doing right now, I think, is the horseless carriage approach. So when cars were created, the first name for them was horseless carriage. So we used to ride carriages being powered by horses, and then we attached a motor onto it, and somehow it became nicer. And I think right now we are in the era of horseless carriages for coding. And the same story happened with Maria Curie-Skłodowska, which you probably know. So when she found out the pollen and the radon particles, they put it into everything. Like, oh yeah, hell yeah, throw AI everywhere. It will solve every problem. And it actually works surprisingly well in many, many places. However, it's like nice to think if we actually need this in this place. So like the old saying before LLMs was that if you are a great ML engineer, you know when to say, hey, you don't need AI for that. And I think we forgot about it a bit these days. So how we code with AI right now, I would like to give you a brief overview of how I see we are doing this today. So for code review and like this missing puzzle for understanding code, there are a few companies that do code review for you and highlight all of the things that agents might have missed. I think the most common ones are CodeRabbit and grep, and they can extract some stuff for you. Yeah, you can try it out if you haven't. So the next thing is that, okay, but how my workflow for coding actually should look like. You probably have heard about Boris Cherny. If you don't know, he's the creator of Claude Code, and recently he shared what is his workflow for coding. Like basically what is the most important is that he works with agents in parallel and and a lot of stuff. I won't go over it step by step, but yeah, you should read it if you haven't. And like one of these things he said that, okay, we can work in parallel, but how to actually achieve it well. So people right now say that, okay, work trees is the way to go. And this is a bit difficult for many people, or some people find it hard. And there is an application for that. For example, it's a conductor. It creates a work tree for you by a click of a button and then integrates seamlessly into your Git workflow. So it's much, much easier to see. And like this is one of the ways to solve it. But if you know this guy, he's a creator of OpenClaw. He said, oh, actually, I don't care about any fancy things. I just pull my repo into few folders. I always work on main. I just ship stuff and basically push it to my repo, and I want to make my workflow as simple as possible. So basically, I would summarize it that like many people say, oh, I just vibe code and it doesn't work. And this is like a stupid person approach. Some people say, oh, you have to make your workflow very, very complex. You have to have specs. You have to use this for your code review. You have to use work trees. And like the super intelligent person will be say, oh, I just vibe code. I just want to ship code and I absolutely don't care. So basically what I'm trying to say is that we are still very early and people are trying to figure it out. And like people have many, many different opinions. And what is most important is what works for you. And like the next funny thing that I have seen recently, you probably have all seen a post from Andrej Karpathy about vibe coding, and he kind of invented this phrase. And we started with vibe coding last year, and everyone was like, "Oh yeah, this is the future. We have to use it." And you could build like simple apps with it. And then people said, "Okay, so now we want to make something more complex. So how do we actually scale this AI to work for us and to ship production code?" So we then switched into a approach that is more structured. For example, this is one that I actually quite like, which basically says you have to do first research of your code base, then you have to do the plan, and then go with the implementation. And there are many different approaches to like make your workflow a bit more complex. But again, what I have seen recently is that, oh yeah, just vibe code stuff and ship it to production. And more people are doing this, and it kind of works. So last week, I was talking to a team that creates codecs, and I asked them, hey guys, do you vibe code? And they said, oh yeah, like codecs app is fully vibe coded. Like maybe not fully, but in a big part is I just put a prompt, implement a feature, and it goes to production. 2 minutes later, a guy came to him saying, hey, my codecs app actually doesn't work. Scaling doesn't work. And so, yeah, that was funny that even OpenAI and people who allegedly knows very well what they are doing and should be very serious about apps that they ship to millions of people are like, oh yeah, we just vibe code them, which is funny. So still coming back to the meme, like basically we care about shipping a lot of code that is high quality. So like what's next? Like this seems a bit messy, and I show some counterintuitive things, or at least contradictory to each other. So how I see we should move in the future to like make our coding with AI and agents more scalable. So I asked this very question, Greg Brockman, he's co-founder of OpenAI. So would agents basically become so good at it that me as a developer, I would be substituted by coding agent, and then I'm becoming my boss or even boss of my bosses. AI gets better and better. And he said that, yeah, probably this is possible. We can squeeze so much more from AI and this might work. But then I asked him, okay, so shouldn't we like actually use the structure of the code that we have here? Like I was saying, the files functions, function calls, classes, and so on, or should we just throw it in? And he said like, oh yeah, I don't know, we'll see, but maybe this is just, we should do the mix of it. So yeah, I guess even at OpenAI, I don't know exactly the answer. And which is very interesting, a GitHub CEO just raised $60 million to build his new startup, because he sees that right now we are producing so much code that it's very hard to trace how this code was actually created. And he wants to build many products on top of that. And the first thing that he's building is basically a new kind of Git blame, which shows how this line was created, what was the prompt, what was the context, and everything about the change that we tried to ship with this very line of code. And this is to some extent open source. You can also see for yourself how does it work. So I do think that basically we are in the horseless carriage era, and we should think about what we are doing differently and kind of redesign our workflow. So I think for humans, we shouldn't read code, but we should understand what is happening and be able to manage it and verify it. And for agents, it's all about context engineering. The better context, the better output, and context for agent always should be as small as possible. So for humans, there is a web application where you can put in your code, and you can see a full call graph of your repository, filter out the stuff that is not that necessary. And now on this bird's eye view, you can select a module that you're interested in, and you can see which part of the code base is responsible for which feature. So for example, this is fast API library. Maybe I'll zoom it in. Okay, a bit bigger. And here you have listed all of the modules, functional features that your code base does. For example, endpoint orchestrator, endpoint dependency engine. And then on the graph, you can see which part of the code base, which functions are actually responsible for implementing this feature. So you can basically see what is the scope of it. And then you can put this to your AI agent so that it can navigate your code base a bit better. And now, okay, this is a high-level view, but what if I care about the logic, how this is actually implemented? So then you can do a deep dive and select the process that you're interested in. Basically, this is the list of the same processes that you have seen there previously. And you have a complete flow diagram showing the business logic of your application, starting from the entry point. And here on the diagram, every element of it maps directly back to the code, so you can verify it yourself, but focus on the functionality itself. And then if you want to dive in deeper how something works, you can just double-click it and explore another diagram that shows you how this works. So this is the way to see the flow and how things actually work. But our coding agents, if we let them free, they are very eager to make mistakes in your repository. So what we can do about this? So this is improvements tab, which shows what you can change in your code base to make it better from many points of view. For example, here we have that code listing all of the functions that are not called by any function. So basically not needed anywhere. High complexity functions that are very complex, so have many ifs, for loops, and so on. AI agents are very eager to implement those. And very long functions. You have also probably seen this. This one is like 900 lines long. So yeah, good luck trying to understand that. And you can try it for yourself as that use Paradigm and throw in your repository either zip or via URL. And I'm basically experimenting how we can understand code bases better. So this was for humans, but what we can do for our agents, because we care to actually ship stuff. So Claude tells us that if our code base is becoming more complex and messy, all you have to do is basically spin up more agents, use more tokens, and they will explore it and come back to you. And yeah, this scales to some extent, but still it takes a lot of time, and it feels like, putting AI in the places where you don't actually have to do this. Then there are LSPs, and Anthropic also added Pyrite LSP, for example, for Python into Claude Code. And this is kind of some sort of a way to make agents navigate code bases a bit better, but this is very, very limited in possibilities, because this only allows agent to see from which places a given function is being called, and then see which functions are called by the function we are in. Then there are another plugins like Serena, which is a bit more complex LSP usage. It also allows to edit stuff a bit more efficiently and so on, but still there are no comprehensive ways to give your agents a view of your code base. But how can we actually then give the structure like this that we have here? So I've made an experiment and I asked Claude, how does this repo work? And after 1 minute and 23 seconds, it gave me this answer. This repository was still quite small, and even if it was, when it's small, it took Claude quite some time to actually explore it properly. And then I did exactly the same question with Paradigm MCP, and it was able to tell us basically the same information within 10 seconds. So already we see a great improvement, and it was also much, much, much less prompts. This is like very basic experiment. I'm working on some more complex benchmarks, so don't worry. And yeah, you can check it out for yourself. So in summary, I see that we are still very early in the process of putting AI coding agents into our workflows and using them efficiently every day and scaling even to the complex production applications that we have. And I'm trying to figure out what is the proper way to do this, and how can we manage code as we get more and more of it shipped with AI. So I'm looking for feedback, design partners, and if you are trying to figure out how to implement better AI coding into your workflow at your company or anywhere, I'm happy to talk and help you with that. And here's a link to Paradigm that I have shown you, and this is my LinkedIn. Thanks.
If you have, okay, I'm coming. Two questions. How expensive is it to do the whole analysis of the code base? For example, for Fast API, I'm not sure if you know the amount of lines of code that the library has. And the second one is, how long does it take to do it? So how expensive and how long?
Mm-hmm. So from the pure AI costs, if you use the best model, which you probably don't have to, is like $1 per 10,000 lines of code. But this could be much, much cheaper and optimized. And yeah, the second question was, how big is Fast API? Yeah. How long does it? Sorry. So right now we just implemented parser for Python that is able to parse 800,000 lines of code in 10 seconds. So it becomes very, very efficient. And once you onboard it, you just have to onboard the changes. So when you are making a PR, it's super quick. And then actually, what is like the biggest use case? When you have a PR, you actually care to see which module it changes, and how does it fit into the rest of your code base. If your change is like very, very low level and encapsulated, or is it like changing a fundamental things and the way your code base work? And then you also see this in the diagram.
Okay, one more question then. TypeScript when?
Soon, very soon. Like literally, I have it working locally, not yet deployed.
Do you have any kind of MCP? I see that like for this kind of project, I'm imagining that you can easily feed it to Claude Code to understand your code base better than like a simple search.
Yes, exactly. MCP is not yet published, but that was literally the experiment that I did here with these two searches. So yeah, I completely agree that Claude Code or any coding agents, for instance, should be able to know that you have these modules in your code base, and those are actually the functions that are used to implement this module.
I have a question that is maybe less technical. We all vibe code probably here, and we know it works sometimes. But there are maybe a bit more regulated industries where you want to serve maybe certain enterprise customers. You need to have some certifications like SOC 2, and essentially you need to do code review. because it's the best practice. And do you have any insights on will that change? Will the industry as a whole move towards like not doing code reviews, just trusting the agents, or how will that work?
Yeah, so like what is the reason of code review? So one of the main reasons right now is to sync your colleagues with the changes that you have made, but this is completely useless right now, and code review should look completely differently. So the interface, when you have a green, the new changes, and the deleted part red, is like completely outdated right now. So that's the first thing. We should do this completely differently. The second one, for regulated industries, I'm afraid that they would actually make more regulations, because people will use, even in the banks, which is actually quite difficult to get AI agents there for you to code stuff. I think we'll get some regulations that would prompt people to like verify it manually. Or what we actually care about is that we want to make sure that the code we ship is correct, has no bugs, has no security issues. And if we would be able to somehow verify it properly, I think then we can get rid of code review. And some people actually get there on a like smaller scale in their toy projects. So some people say, oh, I have tests, that's good enough for me. And I guess this really depends on the application that you are building, but test-driven development is good for that. So especially when you start with the business logic that you want to test, and completely don't think about the technical implementation. Because if you start with code and would say, oh, give me test to that, you would completely fail. Oh, sorry. In a second. Yeah.
Yes, I have a question about the benchmarks that you did for code exploration. So I'm curious, have you tried to use like, there are default architectures for the services, at least for backend services. Like I'm biased here, I'm backend engineer, and we have like kind of standardized way of building services. So this should reduce the discovery time dramatically. So have you tried that in your test, or you had like some general graphs? Or
right now it's very general, but I think you touched on a very important thing, and I think this might happen, that we would see like less patterns for implementing stuff. We would just say, okay, those are two ways to implement backend, and we always do this way. So then your agents would be able to explore it like more efficiently. And this would be easier for humans to understand, because right now every team usually does it completely differently, and every company wants to have standards that they stick to, and this is what makes them scalable.
yeah, to add to that, sorry, quickly. So there are already standards like in the industry. So is it possible to adapt them and taught agents to work in that architectures? I mean, like, I don't know, clean architecture. Everyone heard about it. Some of us use it, and everyone sticks to it perfectly. We skip all the not important parts. But what I'm trying to say is, like, if we taught agents to work in that architecture, so can we, like, stop vibe coding and vibe the proper architecture for the app?
Yeah, like literally, this is the data that you have there on the internet. Like, what is the clean architecture, and a lot of code that is implemented in this manner. So I would say that already agents are very biased into implementing that. But because they don't have a holistic view of your code base, then they don't see all of the modules that there are, they are not able to do this as efficiently. Maybe if we get a bigger context windows, this would get better. But then still, bigger context window, context rot, and quality actually goes down. Thanks.
Yeah, I had a question. So, like, I see how the graph structure really helps to understand the code for humans, but what's the format in which the code is presented for the agent in the MCP? And like, what's the... I don't get this part.
Yeah. So basically, how
What's more
to
efficient way? Yeah.
put this graph into context of agent efficiently. So the most naive way is to say, hey, this is the name of the module, this is the description of the module, and those are these functions. But and this is already a big improvement from what we have. And like putting to the context of your agent all of the edges that there are is probably not the best idea. So it's also then good to look at the actual structure of this graph, and then you can actually tell which nodes are more important and which are less important. For example, it seems that this one calls many functions and this one is not called by anyone, so this is probably the one that we start the process from. So maybe let's say that this is the most important one. We start from here, start your exploration from here, and then explore it that way. And those like that are only called once, we probably don't have to look at all. Oh, actually, this is the start of the process. So chat. So we'd say that, okay, first take a look at chat and then explore the rest of the graph.
So the point is graph structure is better than similarity search on embeddings to explore the code base, right?
Yeah.
That's like the hypothesis.
Yeah.
Interesting.
I mean, especially if you want to give a very, very high quality scope of each feature. Because if you would do grep and you say, oh, how does my chat work? It would probably find this function and this one because it has chat, but it would completely forget about, I don't know, get annotations, and this might be important. Yeah?
I had a similar question. I was wondering how agent will consume the data, because I mean, I am thinking as some sort of maybe knowledge graph and some sort of querying the knowledge graph, because it's just hopping from one node to another, and I'm wondering how this is like planned to be solved. And also, following up on the other question, yes, I believe it is a necessary layer for agent to understand what's the code base about, but without pairing this with the embeddings, it will lose some part of potentially very important context as well, right? Because you might have a similar pattern or a similar way of solving the same problem in a completely other side of the graph, because it's a different feature, but for some reason it is relevant, and you don't know it upfront.
Yeah. So first thing, for example, Claude code is pretty good. It doesn't use embeddings. We probably don't need to have them. And then to like answer the question, what if there is like similar functionality already in the code base? You can just put the list of all of the modules that you have there with a description of what is happening within those modules. And then if it's needed, maybe explore the actual like structure of it and the most important functions first. So this gives you like this full view, and then you don't have to do embeddings. And I think if any embeddings were to be actually made, I think we have to rethink them and like use the graph structure also to do the embedding. I think this would be a very interesting experiment.
Yeah, but what you're saying is that we'll need to do like a dry run of the entire code base and annotate the modules with some kind of metadata. What is it supposed to do? Why is it important? But that's text, and text is for LLM will be embedding at some point. So it's actually easier to just embed the meaning of the module and look for the embeddings rather than text, right?
Yeah, I mean, that's also doable, but I think if any, I would embed this description of a module, and this could be much stronger signal than, yeah, just embedding code, right? Because code is so similar. And if you would put the business meaning where you have this module, the embeddings would be much, much richer. Yeah.
Do you have any idea how to track the motivation for the changes, for example? Because along the evolution definition of a code base. Yeah, people know it, the people who work on the code base, but we get lost in Jira, Notion, stuff. It's very different to like keep it in sync, and for me at least, it's even difficult to imagine how to do it correctly.
Yeah, absolutely. And that's why we humans are still needed, because we know Jira and we have the full business understanding because we were on these meetings 2 months ago, for example. And I think that this data that you mentioned also should be included in this graph. And that's also something I'm working on, but in the future, right? But like literally, we should have information about this module, and you had 20 Jira tickets related to it, 5 meetings, and some legal documentation also related to it. So now I have full picture, and this module exists because of XYZ. Yeah, question in back?
Thank you for the presentation. I have a question about what are the best practices to keep documentation in the era of agentic coding, vibe coding, whatever. So what I mean is that how we should keep docs in the code base. And there was a question on another session today that maybe we don't need docs because agents can read everything. But then the outcome was that actually for large code bases, the agent can eat up all the context on exploring the database. And I wonder how your tool can help with that. And if that could be a replacement of the documentation, and if not, then how to keep docs. And one more thing is that still in many enterprises, documentation is kept in some internal wiki pages. So should they be moved to code bases, or maybe they should be still accessed by some MCPs? Yeah, that's it.
I think MCP is the answer. So getting it basically from your internal source. Let's not like change everything people are doing right now, because then we'll probably fail. And for the documentation itself, I think that just doing the most naive way. So for like every function and so on, like we have it right here, you get it for free. But it's what we actually should use, because like you mentioned, it would clog up all of your code context, is to leverage the graph structure and have documentation also in a hierarchical manner. So first you'd have a description of the whole code base, then you'd have a description of a individual module, and then you'd take a look at the description of a given sub-module, so that you don't clog up the context. Because once you explore the code base once, you can look at the insights that you already extracted. And this is true that on like every level of abstraction in your code base, you actually care about different stuff. So you should have a different documentation for that, so that your agent doesn't have to like re-explore the code base all over again, or Claude spinning up 50 agents to explore some part of your code base.
Thank you. We unfortunately ran out of time for this presentation. So thank you very much.
Thank you.